In this video, we'll be looking at how to prove this Trigo identity, sine squared 2x bracket cotangent squared x minus tangent squared x equals to 4 cosine 2x. Proving of trigonometry identity is a very common O-level A math question. So let's get started. Alright, let's prove this Trigo identity together. So we have sine squared 2x bracket cotangent square x minus tangent square x equals to 4 cosine 2x. So we see double angle as well as angles in terms of x. So very likely we need to make use of the double angle formula. So we have sine 2x here, we also have cosine 2x here. So we will make use of the double angle formula for sine as well as cosine. Okay? At the same time, we also see cotangent square x and tangent square x. So we see cotangent square x and tangent square x. There is an identity that has cotangent square x, and there's also another identity with tangent square x, right? So let me write it out. So the identity with cotangent square x is cotangent square x plus 1 equals to cosecant square x. And the identity with tangent square x is tangent square x plus 1 equals to secant square x. Alright? Okay, so I also have an identity, a double angle formula for sine 2x, which is sine 2x equals to 2 sine x cosine x. So in other words, I know that sine 2x squared will be equals to 4 sine square x cosine square x. Alright, don't worry about these formulas here. These formulas are inside your formula booklet, so you do not need to memorize them. Okay, just need to know that you can get them from your formula booklet, which is the next page after your cover sheet of your additional math exam paper. Okay, now, so what I'm going to do is I'm first going to copy out left hand side, which is equals to sine squared 2x bracket cotangent square x minus tangent square x. Next, I'm going to change sine squared 2x into 4 sine squared x cosine squared x. Okay, and I'm going to change cotangent square x into cosecant square x minus 1. Similarly, I'm going to change tangent square x into secant square x minus 1. Now I'm going to simplify everything. So I have 4 sine square x cosine square x. Okay, and inside this bracket here, when I expand it, I know that I will have, okay, this becoming a minus and this becoming a plus. Okay. Okay, then I have a minus 1 plus 1, which will give me 0. So in other words, I know here I'll be left with cosecant square x minus secant square x. Okay, next, I know that cosecant square x is 1 over sine square x and secant square x is 1 over cosine square x. So I'm going to change these two. Alright? So I'm still going to copy 4 sine square x cosine square x. Then I'm going to change cosecant square x into 1 over sine square x and secant square x into 1 over cosine square x. Next, I'm going to expand. So I have 4 sine squared x cosine squared x over sine squared x minus 4 sine squared x cosine squared x over cosine squared x. So for this term here, I'm going to cancel away sine squared x. So I'm left with 4 cosine squared x. For this term here, I'm going to cancel away cosine squared x. So I'm left with 4 sine squared x. So I have 4 cosine squared x minus 4 sine squared x. Next, I'm going to factorize out 4. So I have 4 bracket cosine squared x minus sine squared x. I need to prove that it's equals to 4 cosine 2x, right? So if you take a look at your formula booklet, you notice that you have this formula, cosine 2x equals to cosine squared x minus sine squared x. So in other words, right, this cosine squared x minus sine squared x is equals to cosine 2x. So I can change this to cosine 2x. And I get what I need to prove on the right hand side, which is 4 cosine 2x. Okay, so I've proved the Trigo identity in this O-level A math question.